Sorry.
Yeah, I wondered what, I was almost ready to call you because I didn't have any audio.
Yeah, the problem is I was trying to get it on my Mac. Like I didn't do anything different with my Mac, and then it said like I needed an update, and I can't update it for some reason. So I just downloaded it really quick on my
I see.
phone.
And then you had to reset the audio to mic and speakers?
Yeah. So.
Okay. So how's it going? What are we going to do tonight?
So we're going into reciprocal functions, so co-functions, so pretty much secant, cosecant, and I think that the third one is that.
What's the reciprocal of tangent?
Tangent, isn't it 1 over, or isn't it just 1 over tangent of theta?
1 over cotangent.
Cotangent? Okay.
Which leaves the secant and the cosecant to go with the sine and the cosine.
Okay.
The cosecant goes there, the secant goes there. And notice that all three relationships have one co. There's the co in this one, there's the co in that one, and there's the co in that one.
Okay.
So as long as you can remember cotangent goes with tangent, you can always figure out which one goes with sine, which one goes with cosine.
Okay. Let me just write that down.
And of course the reverses of these are true also. In other words, if that's the reciprocal, then this is also true.
Okay. I'm just writing it down.
So there are 6 reciprocal relationships.
Okay. Secant. So that's SC. And then isn't secant SEC Oh, okay. That's a little different than what we're learning it through.
Well, now hold on a second.
Okay.
They're not using 3 letters for these?
No, I think she just gave it a different way. She was just saying, let's like just CSCs. She just went H over O, hypotenuse over opposite. And that's all she kind of wrote. We're still using the 3 letters.
You start out with SOHCAHTOA, and that defines the main 3, these 3 here.
Yeah.
So as long as you know these 3 are reciprocals, then cosecant, instead of opposite over hypotenuse, it has to be hypotenuse over opposite.
Oh, yeah.
Okay. So you don't really need to learn, you don't need to memorize what these are. As long as you know they go with these 3 and you know this, then you can always figure it out.
Okay. Okay. So we moved into, it says Pythagorean identities.
There's 3 of those. Here's the number 1.
Okay.
And these are all ones you really want to memorize. These 6 reciprocal, the 3 Pythagorean, and the 2 quotient. Those are huge. You must know all 11 of those. Okay? This is fairly easy right there. Just remember sine squared plus cosine squared is 1. The next one is a little different. It's tan squared plus 1 equals secant squared. Okay, so you have to memorize that one also. The third one is the same as the second one, only using cofunctions. Now, for a moment, let's talk about what cofunctions are. Cofunction of sine is cosine. The cofunction of secant is cosecant. And the cofunction of tangent is cotangent. In other words, you just stick a co in front of the word.
Yeah.
Okay? And what is special about the cofunctions is the sine is always equal to the cosine of 90 minus theta in each of these, and vice versa. In other words, the sine of 60 degrees, or I'm sorry, the sine of 30 degrees is going to be equal to the cosine of 60 degrees, always.
Okay.
Same with, now, these are cofunctions. Don't confuse them with the reciprocal functions.
Yeah.
Okay? The only reason I brought up cofunctions now was because when we go to look at the third Pythagorean identity, it's the same as the second, only using the cofunction.
Okay.
So it's cotangent x plus 1 equals cosecant squared. So you don't really have to memorize that one. You just have to know that it's the cofunction of the second one.
Okay.
There's a secret to memorization on this trig. In other words, there are 11 identities you must know. 6 reciprocal, 2 quotient, and 3 Pythagorean. But you really only have to memorize 7 things. You have to memorize the first 3 reciprocal, and if you use that cofunction, that co-pair thing that I said, then you really only have to memorize 1, and that's tangent. And you only have to memorize this one and this one of the Pythagorean, and then the last 2 are the quotient identities.
Okay.
Tan equals sine over cosine, and if you know that one, you know what cotan is. What's cotan?
Cosine over sine?
Yeah. So this is the only one you got to memorize. Okay. What kind of problems are you getting regarding this?
So there's one that's saying sketch a right triangle corresponding to the trig function of the acute angle, and then it says theta, and find the other 5 trig functions of the angle.
Okay.
And then
What's the trig function they give you?
so it says cotangent, COT, of theta equals 3 over 2.
Okay. What quadrant is it in? Because they're going to give you quadrant also, unless they're just assuming it's first quadrant at the beginning.
I guess because we haven't really gone through a big amount of quadrants, so I'm guessing it's not.
We're going to assume this is first quadrant. Does matter. Okay. First thing is draw a right triangle and label theta. Okay. Now how can I dimension that? If I know the cotangent of theta is 3 over 2, that allows me to put dimensions on 2 of the 3 sides of this triangle. Which 2?
Oh, isn't it, wouldn't it be the bottom? That one would be,
the top is,
that would be,
excuse me, I got it backwards.
yeah, that'd be 3, I think. 3 and then 2. Or yeah.
The tangent of theta would be 2 over 3, making the cotangent 3 over 2. Okay, now that we have 2 sides of that triangle, what's the third side?
You could just do Pythagorean theorem. So it'd be 2 squared. I got a square root of 13.
Correct. Okay, so now we have all 3 sides of the triangle, and we can figure all 6 trig functions. Sine of theta is what?
So, sorry, say that again. Okay. That's 2 over square root of 13.
Rationalize it.
Oh, so then, let me do that really quick. 2 to the square, wouldn't it just be 2 to the square root of 13 over 13?
That's always the way they rationalize. In other words, 1 over root 5 is always root 5 over 5, so forth and so on.
Okay.
So you don't really need to do the math. You just need to know that it always comes out that way.
Okay, so like if I do this in the ACT, should I always rationalize? Will it always be rationalized usually?
It'll depend on your multiple choice answers. But yeah, most likely they will give you it in rationalized form. Occasionally they'll give it to you in this form. You know, you're picking from the answers. So if you come up with this as an answer and you don't see it as one of the answers, then you should look for that one.
Oh yeah, okay.
I've seen them have irrational denominators though, so it's not impossible. So what's cosine?
3 over the square root of 13, which is 3 root 13 over 13.
Okay. What's tangent?
2 over 3.
And what's secant?
I'm trying to remember. It's not hypotenuse over square root of 13 over 3. I think. Yeah.
Yeah, the other one was originally 3 over root 13, so this is square root of 13 over 3. Unfortunately, once you've rationalized it, the cosine, and now you take the reciprocal of it again, now all of a sudden you got to rationalize it again.
Yeah.
So that can be a little tricky.
Yeah.
And what's the cosecant of theta?
I have to rationalize it really quick.
No, you don't.
Square root of 13 over 2. Oh, wait, no, you don't. Yeah.
In other words, I had that in unrationalized form, so.
Yeah.
Okay. That's the way you do those. Now, these will get more complicated and they'll be exactly the same as this, but they'll add it's in the second quadrant. Okay? The only thing that changes is the sign on each of these. In other words, signs, by sign I meant plus or minus sign. That stays positive. This becomes negative.
Oh, yeah.
This becomes negative. This becomes negative. And this stays positive. So you do the process exactly the same. You still draw a regular triangle and dimension it, come up with a number, and then add the plus or minus sign at the end.
Okay.
Okay.
So next they're saying use the given function values and trig identities to find the indicated trig functions,
Okay.
So it's saying tan of theta equals 5. And it says sine of theta equals negative 5 over the square root of 26.
See there, they gave you an irrational. Okay.
And it's saying to find the cotangent, the cosecant,
Okay.
the tangent, and the...
What's our first step?
Well, you could... I'm trying to think.
Draw a triangle.
Oh, okay.
Always. That's the first step. And label theta. Because if you don't label theta, then you could be working in the wrong angle.
Oh, okay.
So the tan of theta equals 5. What can I dimension?
Wait, the tan... Oh, okay. Wouldn't that be negative?
Hold on. They
5.
No, they told you it was 5.
Okay.
So it's got to be 5 here and 1 here.
Okay. And then,
So the square root of 26. Now, how is it that sine is negative and tangent is positive? That tells us what quadrant we're in.
Isn't that a 3?
All students take calculus.
Yeah, want to be in the T.
Has to be in the third quadrant. That's the only place where tan is positive and sine is negative.
Okay.
Okay? So, this is like I was just saying, we're in the third quadrant. Okay? So let's figure out what cotangent is.
Let's see. Wouldn't it be 1 over 5?
It would. What else do you need to figure out? Cosine?
Yeah. And that's it's negative 1 over the square root of 26, but then it's
There you go.
negative 1 of the square root of 26 over 26.
Okay. Secant?
Secant. Hypotenuse over, I always get secant all mixed up. So that's hypotenuse over
I prefer to just
adjacent.
calling it the reciprocal of the cosine. In other words, I know it goes with that because there's one co in that pair right there.
Oh, okay, yeah, that would work actually. So it would be, so one would just be the square root of 26.
Yeah, and it has to have the same sign as the cosine, more importantly. In other words, we don't have to go through the whole analysis again to figure out what the sign is in the third quadrant for secant.
Oh, okay.
Okay, and what's cosecant?
And cosine. And then cosecant would be, let's see, is negative square root of 26 over 5?
Correct. That's it. Okay? That's a more typical problem, where they give you one trig function, and then they give you another trig function just to pin down the quadrant that it's in.
Okay.
Or instead of giving you that, they may have said theta is greater than or equal to pi and less than or equal to 3 pi over 2, which also puts it in the third quadrant.
Okay.
So they're going to give you enough information that you're going to be able to fully label the right triangle and figure out what quadrant you're in.
Okay.
Except for the last question, and they didn't tell you what quadrant you were in, so we had to assume it was first.
Yeah.
But most of these are not going to be first.
Okay.
Because that would be too easy. They want to make you think a little harder. So.
Yeah, okay. Yeah, I just need to remember all students take calculus thing, and that'll help a lot.
Yeah.
So what they have next is, it's the same kind of thing. It's going to be secant of theta equals 5. And then tangent of theta equals 2 to the square root of 6.
2 square roots of 6, like that?
2 square root of 6, yeah.
Okay. I thought you said 2 to the square root of 6.
Oh, sorry. I might have.
Okay. So what quadrant are we in?
First.
Yeah. Because they're all positive in the first.
Yeah.
And this is positive in first and fourth, but this would be negative in fourth.
That would be negative.
So it can't be in the fourth. This could be in the fourth. But the combination of these two tells us we're in the first quadrant.
Okay.
Okay, so
we have to draw the triangle. Hypotenuse, no, that'd be kind of, wait, hypotenuse would be 5. And then the straight angle, or the adjacent, no, the
horizontal
opposite.
side.
Yeah, that would be that one. Yeah, that would be a 1. And then then that would be, the next one would be 2 square root of 6.
Yeah, and we could figure that out ourselves because we know, I could apply the Pythagorean theorem, but the fact they've given us the tangent is that, I know that has to be 2 square root of 6, since I already got a 1 down there. Okay, so now what is sine of theta?
Sine would be 2 square root of 6 over 5.
What's cosine?
1 over 5.
What's cotangent?
That would be 1 over 2 square root of 6, which is 1. Would you have, I always forget, do you bring the 2 with it or no?
Well, let's figure it out. I was just going through that in my head as to what we did. So that's equal to square root of 6 over 2 times 6, 12.
Okay.
So the 2 stays down there. You don't bring it with you.
Okay.
Okay. And then let's see, which one did we not get? The cosecant? Yeah. What's cosecant?
Yeah, cosecant is not, so that's opposite of sine. So that's
It's reciprocal
5.
sine.
Oh, yeah, reciprocal, sorry. So that's 5 over 2 to the square root of 6. And then you have to rationalize that. So
Yeah, and then you can always just do this. That's got to be 5 root 6 over 6 times 2.
Okay, so 12. And then I think we still have cotangent, I think.
No, we did cotangent. We did.
Oh, yeah.
We got 6
Yeah,
of them. We got all 6 of them.
Yeah, we did.
We got sine, cosine, tangent, secant, cosecant, and cotangent.
Okay. Yeah. Oops.
So that's the process. No matter what kind of numbers they give you, you can always go through that exact process. That's almost the quintessential problem for trig. If you could only give one trig problem to a student, that would be it for me.
Yeah. It's the big one.
Mm-hmm.
Okay, so they have next. I haven't really done this before, so.
Okay, what is it?
It's solve the following equations.
Okay.
And it's 4, and it says 0 is less than square root of, or is less than x. And x is less than pi over 2.
That says first quadrant.
Okay. So you just leave it like that?
Well, what's the question?
Oh, it's just saying, oh, yeah, okay. And then it's saying cosine of x equals square root of 2 over 2.
Same problem as the others we've been doing. The only thing is, they gave you this information instead of telling you that it was first quadrant.
Okay.
That's what that means.
Okay.
Dimension this?
Say it again?
Dimension the triangle?
Oh, yeah. So it is, let's see, cosine of x square root of 2 over, okay, sorry, it's just, we did this a little differently, so it's weird to go.
What's the horizontal measurement?
Okay, sorry, 1 sec.
Just substitute
yeah,
numbers.
I'm just having my head just like kind of stopped.
So that's square root of 2, and that's 2.
Yeah.
Okay.
My head just stopped there.
Okay.
So then it'd be...
And then what's this side over here?
Square root of 2 plus x equals 2. So 2 plus... Wouldn't it be 2?
Okay.
No.
I want you to learn how to solve Pythagorean triangles a little faster. I know how you do it. You always start from a squared plus b squared equals c squared.
Yeah.
I'd like you to start from one closer step.
Okay.
Okay? That is, the first words out of your mouth to solve this should be square root of. This answer is the square root of. It's the square root of the hypotenuse squared minus the other side squared. In other words, every side is the square root of something. And inside the radical sign is the squares of the other two sides. Okay? So if I'm doing this directly, rather than have to go all the way back to the beginning of the Pythagorean theorem, I'm going to say it's the hypotenuse squared minus the other side squared. That's the square root of 2.
Yeah, okay.
Okay?
It's a lot faster.
It is. And let's just, for clarity's sake, that was solving for one of the sides, okay?
Mm-hmm.
The only other situation is where you're solving for the hypotenuse. If I have sides of that and that, then the hypotenuse starts out square root of 4 squared plus 7 squared. That's how you do it. Okay? Now, let's say I had a hypotenuse and that side there. Well, this side starts out square root of the hypotenuse squared minus the other side squared always. So that's the only two situations you can have, really.
Okay.
Okay?
That's a lot.
Well, it's just
faster
quicker.
way.
It's quicker, and if you memorize it, you save yourself a lot of time from having to go through write the Pythagorean theorem and then take the square root of both sides and solve it and all of that.
Okay.
So now we have the triangle fully dimensioned. We know we're in the first quadrant, so it's a piece of cake now to list all 6 trig functions.
So how would you actually, like, after you get them all, do you just need to, I'm just figuring how you would solve it after you find out all the functions.
There's no solving.
Okay.
That's it. In other words, their question is, what are all 6 trig functions of x? Excuse me, I should not have said that was theta. That is x.
Yeah. Okay.
Okay? In other words, the answer is square root of 2 over 2. Tangent is 1. Cotangent is 1. Secant is square root of 2. And cosecant is square root of 2. There's your answer.
Okay.
There's no other answers required after you get all 6 trig functions.
Oh, okay.
The only difference between this problem and previous ones is they defined the quadrant by giving us this information as opposed to giving us another trig function. In the previous problems, they gave us 2 trig functions, and that allowed us to figure out what quadrant we were in.
Yeah, that's true. Okay. It's a little different. Okay.
That x will, if I was in the second quadrant, then it's that to there. That says quadrant 2.
Yeah, okay. I'm still learning the quadrants, all those kind of, how to figure them out still, so.
1, 2, 3, 4. They go counterclockwise, the same way the angles go.
Yeah.
In other words, they go in the same order that positive angles go. Your positive angle works its way counterclockwise.
Yeah. Okay. So what we have next was use the trig identities to transform the left side of the equation into the right side.
Okay, this is called verifying trig identity. This is everybody's nightmare except mine, because these are really, really easy if you really know your trig identities well. So what's the first?
Cosine of theta and then secant of that multiplied by secant of theta equals 1.
Okay. Generally, you want to try to move stuff to cosine and sine. So what we want to change here is the secant. What is secant again?
Secant.
trying to make it in terms of cosine. So that's the reciprocal.
1 over cosine. Okay.
Now that over that equals 1.
Oh, so that's 1.
So 1 equals 1, mission accomplished.
Oh, okay.
That's all there is to it. What's another one? They make these pretty easy at the beginning.
Yeah. So now it's parentheses 1 plus sine of theta, then parentheses, and then another parentheses 1 minus sine of theta, and then end parentheses equals cosine squared of theta.
How did I know that? Okay. So let's multiply these two things together. Notice we're looking at the difference of squares factored.
So would it just be 1 minus sine squared of theta?
Good. That's the way to do it. Don't waste all the time refoiling that. In other words, once you see the difference of squares factored, you can put it back together again pretty easy. There was the difference of squares right there. So if I started with this and I said factor it, you would have immediately gone to that. Well, be able to go the other direction also. Now, your first trig identity, your first Pythagorean trig identity is sine squared plus cosine squared equals 1. Well, you rarely see it like that. The place you more likely to see it is this. What's that?
Okay. I was just...
What's 1 minus...
Isn't that just
That's cosine.
Isn't that just cosine squared?
Yeah, in other words, it's the algebraic manipulation of this.
Okay.
So I can replace that with cosine squared. Mission accomplished. And that usually the way you want to do these is you want to work with the most complicated side, which is clearly that side, and you don't want to touch this side over here. You just want to turn this into that.
Okay. Sorry, the page.
But it always comes down to these 11 trig identities.
Yeah.
And the whole purpose of this drill, these verifying trig identities, is merely to get you to learn them. There are no real-world problems where you have to verify trig identities.
Oh, okay.
No.
I always try to compare them to each other.
Well, there are real-world equations that have trig in them. In other words, I can come up, with a certain situation and have it turn into a trig equation that has to be solved. That is real world. But there's no real world where you have an identity and you have to, the only purpose of these is to get you to learn your identities.
Okay.
What's another one?
Let me look. Just kind of close and try to open it back. Okay. So it is sine squared of theta minus cosine squared of theta equals 2 sine squared of theta minus 1.
Okay.
Yep.
Well, let's go back to our Pythagorean identity. And what is that equal to again?
Yeah, going back to my notes, really looking through it.
If sine squared plus cosine squared equals 1, then what does cosine squared equal?
Oh, I read. So sine squared plus cosine squared equals 1. Oh.
Do the algebra. Solve for cosine squared. What do you get?
Cosine squared equals 1 minus sine squared. Theta.
Okay. So now I've got sine squared of theta minus that quantity. So remove the parentheses, what do you have?
So if you remove them, then you... Oh, okay.
You have sine squared of theta.
So sine squared
minus 1, what?
Minus 1. Wouldn't it be another sine?
Plus.
Minus 1.
Plus sine squared of theta, right?
Oh, plus sine squared. Yeah.
Okay, now we got one sine squared of theta there, another one here. That's two of them.
Okay. So then... And then... Yeah, it would work out. Okay. Yeah, okay, I know what I did wrong. I just missed a little step.
Okay, what else you got?
That was it for that. For
Okay.
there's only 3.
Okay. They can get hard. I've had trig identities that I've worked for 25 minutes on and haven't been able to get it. And that's because sometimes you start off on the wrong path. In other words, there's a little bit of art to it on knowing which way to go. And if you go off on the wrong path, even if you use the proper identities, you can get lost in the woods and it's hard to come back from it. Sometimes, usually, if you can't prove an identity, it's best to start all over again. And the maxim is that if all else fails, convert everything into sines and cosines. And go from there.
Okay.
Okay? That isn't what you always want to do, but if you can't solve it any other way, that usually works. Convert everything into sines and cosines and go from there.
Okay.
That's going to hurt you in some problems that have nothing but tangents and secants in them. In other words, if I had tangent squared plus 1 equals secant squared, and I said verify that, well, if I went to the trouble of converting this into sine over cosine and this into 1 over cosine, that just makes the problem harder if I just recognize that I already have an identity for that. It's secant squared.
Oh, okay.
In other words,
Yeah.
this is a case where you'd be making the problem harder by converting everything into sines and cosines.
Yeah, that's true. Okay.
Okay? What other kind of stuff you have?
We started you doing the unit circle. We just started.
Okay.
So we had to go through all, we only went through, I think quadrant 1.
Okay. But didn't I give you my Trig 101 course pretty much in one session?
Yeah.
Yeah, and I drew it all out on the page and I said, memorize this?
Yeah, I took a picture of it.
Okay. Do you have any questions about it?
I don't know if I exit out of my phone, it would exit the actual thing. Because it's on my phone. I don't want to exit I don't know if it would actually end the meeting if I exited my phone.
If you exited your phone.
Because I have my computer, it did not work. The meeting did not work on my computer.
So you're on your phone right now?
Yeah.
Oh, you're the first person I've ever known that has done a meeting on the phone.
Yeah, it's just because I was if I try to write I was trying to write the ID.
Let's do it this way. I don't want you to have anything in front of you. I want you. The way to memorize stuff is to test yourself regularly, not to have a cheat sheet that you look at every single time.
Yeah, that's true.
There's a big disadvantage if that's the way you learn trig. You won't be able to do verifying trig identities.
Okay.
The only way you can really do verifying trig identities is if you really have them memorized. All 11 of them. All 11 of them, okay? So, same with the unit circle. So, help me recreate this.
Okay.
What else do I want to put on there?
I will. So, should we just start on quadrant 1 then?
Well, you tell me where everything is.
Okay, well, let's just put all students take calculus first. I would like to put that there.
That goes, actually this is better to put because this tells you the proper order. and you have to go counterclockwise. So it has to be all students take calculus.
Okay. Yeah, that's right.
And now, angles that are in the second quadrant, in order to convert them to a similar first quadrant angle, what's the formula in the second quadrant that I want to use?
Sorry, say that one more time.
Angles that are in the second quadrant, for example, a 150-degree angle.
When you want to use the, the 180 minus theta?
Yes,
Or is
exactly what I've written there. In other words, if you got an angle of 150, you would plug the angle into theta. That converts to a 30-degree first quadrant angle.
Okay.
And you know most of the trig functions of the first quadrant angles. So that's extremely valuable. In other words, that's very helpful. If we can take any angle in any quadrant and convert it to the equivalent first quadrant angle, we got 90% of the problem solved. Then it's just a question of putting the proper plus or minus sign on it.
Yeah.
Okay? So, that's the formula for the second quadrant. What's the formula for the third quadrant?
Ooh. I remember, isn't it just
the opposite,
like Z?
the reverse of it.
Yeah, 0 minus 180.
Just remember it's the reverse of the second.
Okay.
And the fourth is the same as the second, only it's 360 instead of 180.
360. Yeah.
Now, it's at some point you start working in radians. And if you want to do these calculations in radians, then you're going to use pi minus theta.
Yeah.
If this one would be theta minus pi, and this one would be 2 pi minus theta.
Yeah.
So there's actually two formulas depending on whether you're in degrees or radians.
Yeah.
That's it.
Yeah. I just have to remember the radians a little more. I got the sine and the tangent, but I keep forgetting the 2 pi minus theta.
Well, notice that 180 is equal to pi. So all I'm doing is substituting pi for 180, and 360 is 2 times 180, so it's 2 pi.
Okay. No, that's true.
That's why I don't usually write these, is because it's real easy to add them. And if you memorize this, you'll be in good shape. You'll be able to figure out. You know, worst case scenario is if they give you radians, you can convert it to degrees and go through the analysis.
Yeah, it's just whenever I look at like the comparison between like yours and an actual like unit circle, so much like it looks so much like more.
What is this angle? What is this angle right here?
Right there. Wouldn't that be
What's it
like
look
330?
What's it look like? Okay. In other words, if I'm going to draw it there, that's 330 or 315. But if I'm looking at this angle right here, that is negative 45 because I'm going in a clockwise direction. It just happens that negative 45 is the same or coterminal with 315.
Okay.
So if somebody said, what is the sine of negative 45, you could do it a couple of ways. You could say, well, that's got to be the same as the sine of 315, and that's the same as the sine of 45, which is square root of 2 over 2, but I can tell we're in the fourth quadrant, so I know it's got to be negative. Okay? The easier way to do this problem is not to go through this double conversion. It's to know that the sine of negative theta is equal to negative sine of theta. So when I said, what's the sine of minus 45 degrees, it's much quicker if I say, well, that's got to be minus the sine of 45 degrees. I know sine of 45 is root 2 over 2. I'm done.
Oh.
So by converting this negative angle to a positive angle is actually 2 extra steps, because then you have to reconvert it back to a first quadrant angle. So it's really better to do it this way here.
Yeah, that's a lot faster.
Yeah. And the cosine of negative 45, well, the cosine of a negative angle is equal to the cosine of that angle, because it's an even function. So immediately that's root 2 over 2 also.
2 over 2, yeah. Okay.
It would behoove you to memorize your basic angles.
Okay.
Sine of 30 is 1/2. That's the most basic of all to memorize.
Yeah.
Cosine of 30 is root 3 over 2. Tangent of 30 is 1 over root 3. And of course, the sine of 60 is going to be the same as the cosine of 30. So the sine of 60 has got to be root 3 over 2.
Oh, okay.
Because they are cofunctions.
Okay.
And then the 45-degree angles, it's worth memorizing those as opposed to memorizing those 2 triangles, where you can always figure these answers out from those 2 triangles, but rather than have to always refer to them, really good to memorize those.
Okay.
In other words, you want to fairly quickly be able to do any trig function of any angle that is a multiple of 30, 60, or 45.
Okay. Okay. Yeah, that's a lot easier than memorizing this whole unit circle.
Yeah. What's this equal?
This
What's that equal?
is
What's the sine of 750 degrees equal to?
750. Let's see. So
you first of all have to convert it to a first quadrant angle. How do you do that?
yes. I'm just thinking. So wouldn't that just be 30?
Yes. In fact, that is equal to the sine of 30.
Yeah.
So now this is the problem. That's 1/2.
Yeah. 1/2. Yeah. Okay. Yeah, that's a lot. It's a little easier because on this one they're like, it looks a lot more writing, a lot more memorization. It looks like than just doing.
There's
what you're
one
doing.
thing still that we haven't talked much about, and that is the quadrangles.
Quadrangles. Okay.
90, 180, 270, and 360.
Okay.
In other words, you can't get these off of those 2 triangles. Right?
Yeah, that's true.
Okay. However, let me show you real quickly. If I draw the unit circle there, and I put a point right there. Now I draw a triangle. This distance right there, well, if I take, remember our unit circle is always a hypotenuse of 1.
Yeah.
So the cosine of theta equals x. The sine of theta equals y.
Okay.
Okay? So if I want to know what the sine of 90 degrees is, it is the y coordinate of this point right here. Well, what is that point? That is 0, 1. What's the y coordinate? 1.
1.
That makes the sine of 90 degrees 1. Okay? If I want to know what the cosine of 0 is, well, this point right here is 1 comma 0.
Mm-hmm.
Cosine of 0 has to be what?
That was just 0?
Equal to 1. It's equal to that x coordinate.
Oh, to the x coordinate.
Because cosine is equal to the x coordinate.
Yeah, okay.
Okay? So now, just real quickly here, that allows you to figure out all of them. In other words, when I'm over there, my minus 1 comma 0, so what is the cosine of 180 degrees?
Negative 1.
What's the sine of 180 degrees?
Will it still be 0 or
Yeah,
1?
No, it's the y coordinate.
Oh, so then
The sine,
0. Yeah.
the sine of x is equal to y. The cosine of x is equal to the x coordinate.
Oh, so it'd just be 0.
It would be 0. So let's go down and look at this one, 270. Well, what's the coordinates on that? 0 minus 1.
0, negative 1.
So what's the sine of 270?
Negative 1.
What's the cosine of 270?
0.
That's the way you do the quadrangles.
Okay.
Or, the way I don't usually teach that method because I think it is so valuable to know this chart, to know this graph. And if you know this graph, that will tell you the value of the quadrangles. Because we know that's 90, that's 180, that's 270, that's 360. So if I read this graph and I say this is sine x, okay, well what's the sine of 0? It's 0. What's the sine of 90? It's 1. What's the sine of 180? It's 0. The sine of 270 is negative 1. And the sine of 360 is back to 0.
Oh, okay.
So if you know this graph and you know how to break it up into its 5 points, its quarter points, then you can use the graph to figure out all of the quadrangles.
Yeah, okay.
But that other technique is not bad. Knowing that the sine of x is equal to the y coordinate and the cosine of x is equal to the x coordinate. That's pretty fundamental knowledge to have that's good to know. And all of that is based on the unit circle and an angle. And then dropping a vertical from that point there. And this point right here is x comma y. And like I said, the cosine of this angle is equal to x. The sine of that angle is equal to y.
Okay, yeah.
All right. We'll end it there and pick up again next Thursday.
Yeah, okay. I'm going to try fixing this computer. I don't know what happened to it.
Really? I hope.
Yeah, I didn't touch it this whole week, and then this week it's just like...
I'm impressed that you could do this on your phone.
Yeah, that was kind of my last resort. I was like, let's see if they have an app.
Well, this GoToMeeting is quite power hungry. When I'm running it, I can't hardly run anything else on my computer. So you must have a pretty high-powered cell phone.
Yeah, I can see your screen and everything. It's working actually pretty well.
Yeah.
Just I wish it was a little bigger, then I could see a little better.
Yeah.
For it, but other than that, it's okay.
Right. Yeah, that's got to be a little bit hard, but.
Yeah, but it's still in pretty good quality. So.
All right, Anthony. I'll talk to you next Thursday.
Yeah, next Thursday. I'll see you then.